Use the 68%, 95%, 99.7% rule to answer each of the following. The random variable x is normally distributed with a mean of 0 and a standard deviation of 1. Determine the probability that x is between -2 and 2. So that's just within 2 standard deviations of the mean. So that's quite simply just the 95%, so 0.95. Now with x greater than 1, we'll need to think a little more about that one. So 1 is here, and we're after it being up here. Now, because of the symmetry, this is 0.5, and this would be half of the within 1 standard deviation, so that's going to be 0.34. So this is going to be 1 take away 0.84, giving us 0.16. Now we're going for part B. So test results for a group of 200 students are found to be normally distributed with a mean of 60 and a standard deviation of 12. Determine the approximate percentage of students in the group with the test result greater than 96%. Well, 96 is equal to 60 plus 3 lots of 12. So we're talking about students being 3 standard deviations above the mean. And we know that for that we can use the 997 figure. So this bit here is 0.5, and this is half of the 0.997. So 0.997, if we divide that by 2, so that's going to be 0. It's going to go in there 4 times with 1 over. It will go in there 9 times with 1 over, and it would go into 17 8 times with 1 over. So it's going to be 0.4985. So greater than 96% is going to be 1 take away 0.9985, which is 0.0015. And this is percentage, so multiply by 100, so that's 0.15%. So the next part is about expectation. How many would we expect to achieve a result of better than 96%? So what we want to work out is 0.15% of 200, which is exactly the same as doing 15% of 2. And 15% of 2 is 0.3. So that would indicate no students with that score. And 0.3 of a student is certainly closer to 0 than it is to 1